Lesson today is equivalent ratios and tickets. Go ahead and put this in your notes. Here we go. Equivalent ratios, and this is for your notebook, are ratios that have the same value. For example, 1/2, 2/4, 10/20, and 50/100 are all equivalent ratios. All of these can be simplified to 1/2. For example, to get from 1/2 to 2/4, you multiply by 2 and 2. To go from 1/2 to 10/20, you multiply by 10 over 10. To go to 50 over 100, 1 times 50 is 50, 2 times 50 is 100. And these ratios are created by multiplying or dividing the denominator and numerator by the same amount. Here's another example for you. 2/3. If we wanted to generate some equivalent ratios or equivalent fractions, 2/3 multiply numerator and denominator both by 4 gives us 8/12. Those are equivalent. To prove it, 8 and 12 are both divisible by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. 2/3, 2/3. 2/3 and 8/12 are another example of equivalent fractions. Why is this important? Well, when we problem solve with ratios, equivalent fractions are a very convenient way to help us out. This example needs to go in your notes, not necessarily the words, but definitely the numbers. It says the ratio of boys to girls is 12:9. The classroom has 36 boys. How many girls does the classroom have? Again, the order matters. It tells us right in the problem we are talking about boys to girls, which means this 12 represents boys and this 9 represents girls. The first way we can do this is with a table. It's a little time consuming, but it'll work. So the original ratio is boys 12, girls 9. So if we double that, 12 times 2 is 24, 9 times 2 is 18. If we triple it, add another 12 is 36, add another 9 is 27. And the problem says the classroom has 36 boys. How many girls does it have? Well, when we go to our table, here's 36 boys. Here is our equivalent amount of girls, which is 27. Now this table works pretty well in this example because we don't have to go very far. All we have to do is a couple multiples to get there. However, a ticket is a much faster way. So we know we're comparing boys to girls. And how do we know that? Well, it tells us right in the problem. It also tells us we have 12 boys and 9 girls. So far we haven't done any math. This is just the given information. Boys to girls, which is 12:9. When we go to the problem, it tells us the classroom has 36 boys. So we can think about this and say, okay, we know we're keeping track of the boys in the numerator, so there's my 36 boys. How many girls does it have? This is what we're trying to figure out. We don't know how many girls this has. That's what we're trying to answer. But I know that 12 times 3 gives me 36, so if I multiply the numerator by 3, I also have to multiply the denominator by 3, and 9 times 3 is 27. So either way, you're going to get 27 girls as your answer. However, the one on the left is much quicker, especially as we get to larger numbers. Okay, before we go over this one, why don't you take a minute, pause the tape, and give it a try. Okay, one serving of Mike's crackers has 300 calories and a mass of 30 grams. Right away, I can see that what we're comparing here is calories and grams. And I know before I read any further that it has 300 calories and a mass of 30 grams. So right away, I'm going to record the information I have even before I start reading. So how many calories are in 10 grams of the crackers? So, I know that 300 calories is in 30 grams, and we want to know how many calories are in 10 grams. Well, if I'm talking about 10 grams, I'm keeping track of grams in the denominator. And what I'm trying to find is, okay, how many calories are there? So this is a really similar problem to the first one. However, in this case, I'm going from 30 to 10. And I know in my last example, in order to go from 12 to 36, I had to multiply. And this one I'm going to have to divide. And 30 divided by 3 is 10. So to find what my answer is, how many calories there are, 300 divided by 3 is going to give me 100, which means there's 100 calories in 10 grams of the crackers. With a calculator, one thing you can do to check this is go ahead and just punch this right in. 300 ABC 30, it'll spit out a number for you. And if you type in 100 ABC 10, it should spit out the same number since they're equivalent. Okay, one example with fractions. To clean a tank, 3/4 cup of disinfectant is needed for every 2 gallons of water. How many cups of disinfectant are needed for 20 gallons of water? First thing I want to identify here is my ticket. And I'm talking about cups of disinfectant for gallons of water. So, I'm not going to put cups and gallons because really what I'm talking about is how much disinfectant I'm using for a certain amount of water. And I know one thing that was confusing to people when we did this earlier in the year is that you thought the original ticket was 3 to 4. But it's not saying 3 cups of disinfectant to 2 gallons of water. It's 3/4 cups of disinfectant for every 2 gallons of water. And you're going to see this complex fraction a lot more in 7th grade. But the ticket helps you to understand disinfectant is 3/4. Water is 2 gallons. And as we keep reading, how many cups of disinfectant? Well, obviously that's a question. How many cups? We don't know. Are needed for 20 gallons of water. So really what happened is we had this original amount, and it looks like what we did is we took this original amount and we multiplied it by 10, which means we're going to have to multiply the amount of disinfectant we have by 10. So on your calculator, you're going to have to do that. You're going to need to type in 3/4, 3 ABC 4 times 10, and you'll find out that really what we're using then is 7 1/2 cups of disinfectant for every 20 gallons of water. Take your time and copy this example into your notes. If you need to rewatch it, rewatch it. All right, go ahead and pause the tape and try this one on your own. Okay, first thing you should have done if you did this correctly is make a ticket, and what we're talking about is sugar to water. She's making Kool-Aid. Those are common ingredients that you need. The next thing you should have done, how much sugar is in the original recipe? 1/3 of a cup for every 4 cups of water. And this is a good example why I didn't use cups as my ticket, because both units are in cups. What we're talking about is cups of sugar and cups of water. So that's what I use as my ticket. And it looks like she used 24 cups of water, which means she multiplied by 6 to get there. And on your calculator, you'll do 1/3 times 6, and you'll find out that means she used 2 cups of sugar for that recipe. Okay, this is the last one you need to do before you get to your work. Go ahead and pause the tape and try it. Okay, in this problem, he uses 2 parts butter for every 3 cups flour. So butter 2, flour 3. Now, I'm not going to give you this answer because your job is to plug in each answer choice and see which one's equivalent. One thing I will tell you is you can think logically through this. If it's 2 butter and 3 flour, that means you're always going to be using more flour, which is the second part of the ratio. So when I look here, answer choice B, that doesn't seem right to me, because this one is using much more butter. So now it's narrowed down. Once you have this, go ahead and go to the bit.ly. It's bit.ly/ISR2 2019. The I, S, and R are all capitals.